Let us see various biasing techniques used to bias bipolar junction transistor. In fixed bias circuit, the base bias is provided using a fixed value of resistor RB. In collector to base feedback, the base bias is given through collector feedback using RB, whereas in voltage divider bias or self bias, the base is provided a bias using voltage divider network R1 and R2 by deriving voltage across R2. In collector to base feedback, emitter resistance is used. Also, in cell bias or voltage divider bias network, emitter resistance is used. This emitter resistance provides stability to the network by providing negative feedback on input side, which is not available with fixed bias circuit. Compared to fixed bias circuit and collector to base feedback bias with emitter resistance circuit, voltage divider bias or cell bias network found to be more stable. Therefore, we see exact analysis of cell bias or voltage divider bias network to know DC operating conditions of the cell bias network. The cell bias network has input circuit side and output circuit side. This side is an input side, whereas this side is the output side. To solve the input circuit of a cell bias network, one needs Thevenin's theorem and Kirchhoff's voltage law. According to Thevenin's theorem, R1 and R2 can be replaced by its parallel combination in series with a Thevenin's voltage source. The Thevenin's voltage source can be found as R2 divided by R1 plus R2 into VCC, whereas Thevenin's resistor can be found as R1 parallel R2, that is R1 into R2 divided by R1 plus R2. After calculating the Thevenin's voltage and Thevenin's resistor, one can modify the cell bias circuit like this, which can be called as Thevenin's equivalent of cell bias circuit. Now let us apply KVL to both input side and output side of the Thevenin's equivalent of cell bias circuit. Applying Kirchhoff's voltage law to input loop, we can have VTH is equal to ETH is equal to RTH into IB drop plus VBE drop plus IE into RE drop, where VE is equal to IE into RE. Substituting IE equal to 1 plus beta into IB, using IE equal to IC plus IB, that is equal to beta times of IB plus IB. We get IB equal to VTH minus VBE divided by RTH plus 1 plus beta into RE. Now, applying Kirchhoff's voltage law to output circuit, we get VCC equals to IC into RC drop plus VCE drop plus IE into RE drop. Since IB is very small compared to IC and IE, we can say IE is nearly equal to IC. That's why we get VCC equal to VCE plus IC into RC plus RE. Therefore, VCE equal to VCC minus IC into RC plus RE. Substituting IC equal to beta times of IB plus ICO for common emitter type of configurations, where ICO is equal to 1 plus beta into ICO is the leakage that is found in common emitter type of configuration, whereas ICO is the leakage that is found in common base type of configuration. Now, using equation number 2, equation number 4 and equation number 5, one can find DC operating or quiescent operating point, that is ICQ and VCEQ, for given value of IP or given specification. Now let us look at merits and demerits and use of cell bias circuit. Merits of the cell bias circuit is operating point is almost independent of beta variations, hence cell bias circuit is also known as beta independent or current gain stabilized circuit. Further, operating point stabilized again shift in temperature. These are the merits of bipolar junction transistor. There are few demerits of the bipolar junction transistor, as beta value is fixed for a given transistor. One has to keep RE fairly large or make R1 parallel R2 combination very low. If RE is of large value, then VCC requirement becomes very high. This increases cost as well as precautions necessary while handling. If R1 parallel R2 is low, necessarily you have to keep either R1 low or R2 low or both low. A low R1 raises base potential closer to collector potential, reducing the available swing in collector voltage and limiting How large RC can be made without driving the transistor out of active mode? A low R2 lowers VBE, reducing the allowed collector current, lowering both resistor values draws more current from the power supply and lowers the input resistance of the amplifier as seen from the base. Also, AC as well as DC feedback is caused by RE, which reduces the AC voltage gain of the amplifier. But DC feedback can be avoided by using RE bypass capacitor. These are the demerits of bipolar junction transistor. These are the demerits of cell bias circuit. The cell bias circuit, due to its stability and merits, are used widely for linear circuit. Having studied how to derive or how to evaluate the various DC operating parameters, one can solve these examples to find out the DC operating point of the given circuit. Here R1 is given as 39K, R2 is given as 3.9K, RC is 10K, and RE is 1.5 kilo.